Mathematics Department to the 2017 Porcelli Lectures. I'm James Oxford, I'm a member of the Maths Department, and it's my pleasure to introduce Dee Peterson of the College of Science. She is going to introduce our speakers today.
Thank you. Hello, it's great to see you here today. This is a very special event for the Department of Mathematics. Professor Porcelli was a member of the faculty here at LSU. He earned his PhD at the University of Texas at Austin in 1952. He served on the faculty at the Illinois Institute of Technology for some years and then joined the mathematics faculty at LSU in 1959. Not so long after that, he earned the great distinction of being promoted to Boyd Professor, and that was in 1965. Dr. Porcelli directed 15 PhD students here at LSU. Those individuals went on to faculty and leadership positions at many of the most prominent institutions across our country. Dr. Porcelli died in 1972, and the Department of Mathematics honors him each year with this Porcelli Lecture Series. This began in the late 1970s and has continued to present. The department also has Porcelli Awards for graduate and undergraduate students. So it's my distinct pleasure today to welcome to our campus this year's Porcelli lecturer, Ken Ono. So Ken is currently the Asa Griggs Candler Professor of Mathematics at Emory University. He also has held named professorships at the University of Wisconsin, Madison, and at Penn State. He received his PhD in 1993 at UCLA, and his research area is number theory. He has quite a list of awards to his credit. I'll just mention a few of those. He won a Presidential Career Award in 2000, a Sloan Fellowship in 1999, Packard Fellowship in the same year, a Guggenheim Fellowship in 2003, and in 2012 he became a Fellow of the American Mathematical Society. He has been a lucrative researcher with over 160 publications. He's on the editorial board for more than 15 journals. He has had quite a long list of PhD students in his career, including our own Paul Malberg. In addition to having an illustrious research career, Dr. Ono is involved in outreach to the broader community in a variety of ways. He's given a couple of TED Talks. He was featured in 2014 in Scientific American, and I was delighted and honored to meet him today, realizing that he was the associate producer and mathematical consultant for a movie that was very inspiring to me, The Man Who Knew Infinity, based on Ramanujan's biography that was written by Robert Hannibal. So we have a real treat in store for us today. It is my distinct pleasure to welcome you. Please join me in welcoming him.
Thank you. Delighted to be here. Hope to not eat too much because I know the food in Louisiana is outstanding, and we went to the faculty club for lunch, and I have to say I'm not off to a very good start. Food here is wonderful. So, I'm delighted to be here, and it turns out that the mathematics here is outstanding. There are lots of people who do research that's somewhat close to what I do, in some cases very close to what I do, and so if you are a student here, I applaud you for your choice, and if you are still a student here, make sure you make the most of it. There are very strong groups, certainly in number theory, representation theory, and knot theory, and these are only among the subjects that I know something, in some cases very little about, but I do know something about them, and the faculty you have here are doing really great work. By the way, it is true, one of my former students is a professor here, Carl Malberg. Where are you, Carl? So I'm going to embarrass Carl right now. So he was born with the name Carl, right? That is a true fact. And when I recruited him to be a graduate student at the University of Wisconsin, I did the thing that anybody would do, would call him by the first name that was on his application. Is this all right? And I only learned almost 4 years later that all the way through college, he didn't go by the name of Carl. Does anyone here know this? All right, so you're all calling him by the name he doesn't want to be called. He wants to be called Barry, and so maybe he's grown up. He doesn't want to be called Barry anymore, but there was a point in... All right. Okay, let's get started here. So I'm going to give you a talk that's super fun to give. There is a little bit of math in here, and I think the math that I will talk about is important, but I'm also giving some other math talks where the math is much more important. The point of this lecture is to tell you a true story about one of my personal heroes, maybe my only hero, and one of the messages that I want to get across is the answer to the following question: why does Ramanujan matter? And really, why does he matter? And for me, Ramanujan has been not only a role model in terms of his science. As some of you know, I've been following his science for quite some time, and that's an important part of the story. But perhaps more important is why we decided to make a popular film about a mathematician who lived a long time ago. What would that story really be about? And that's what I really want to talk about today. And in particular, we live at a time where I think we need to restore the value to academic and cultural endeavors, and it's for that reason that I think this story is particularly important. By the way, this March for Science is very soon. It's on Earth Day next week, so if that's something that you want to participate in or don't know much about, I invite you to look into it because I think science is important. You see, science usually proceeds by the work of thousands, slowly contributing to a body of knowledge. But every once in a while, there are people like Einstein or Newton or Ramanujan, and their ideas are so profound that they propel human thought forward. We need these people. And in the case of Ramanujan, as I will tell you, is someone who almost never was. He was almost defeated by a completely inelastic educational system. And so keep that in mind, and let me tell you the story. Great. I first learned about Ramanujan on April 7th, 1984. There aren't many dates that I remember. I know my birthday. I certainly know the birthdays of... Actually, I don't remember all the birthdays of my brothers, by the way. But I remember April 7th, 1984. I was 16. I was a high school student. I fought with my parents all the time. And I fought with my parents a lot, basically over school. I was supposed to get good grades, or perfect grades. I was supposed to get a perfect SAT test score. And who likes hearing that? So I fought with my parents a lot, and on Saturday, April 7th, 1984, a letter comes to the house, and this is a letter, and let me read it to you. It's the most peculiar letter. It was addressed to my father, and the letter begins with the words, "Dear Sir, I understand from Mr. Richard Askey, Wisconsin, USA, that you have contributed for the sculpture in memory of my late husband, Mr. Srinivasa Ramanujan. I'm very happy over this event, and I thank you very much for your good gesture and wish you success in all of your endeavors. Signed, S. Janaki Amal." I'd never heard of Ramanujan before, and my father, who was a very stoic man, didn't even cry when his parents passed away, was moved to tears when he got this letter. And I thought that was, of course, very strange. Everything about this letter I thought was strange. First of all, how many letters have someone's face on the letterhead? Honestly, that's weird. And then I saw that this man died in 1920, and I couldn't escape the fact that this was basically a form letter. This wasn't really a letter written to my dad. It was a letter that was written to about 80 people. How special is that? And then up here in the upper left-hand corner, the letterhead reads, S. Janaki Amal, widow of of mathematical genius Srinivasa Ramanujan. And that was like really weird. So this is when my father told me about a little bit about my past. My family came to the United States from post-World War II Japan, a very difficult time. My parents grew up at a time when Tokyo was bombed. Right? My father's high school was literally blown up in some of the firebombing raids. And what happened after World War II was a major conference where my father was introduced to this mathematician named Ramanujan. And he was at a conference where he was together with some of the most important Japanese mathematicians of his generation. The professors in the audience will know these names, people like Goro Shimura, or Taniyama, or Tamagawa, Hironaka. Almost anyone who was anyone as a Japanese mathematician happened to be at that meeting. They were starving, not only for math, but also literally for food. And there they learned about this Indian mathematician who also overcame very incredible hardships to end up changing the course of mathematics. Turns out that all those Japanese names I mentioned to you are people who ended up going on to become very distinguished number theorists working in this field largely because of that meeting. My parents and all of those families came to the United States. They ended up populating faculty positions at some of the top universities, revering Ramanujan, and I didn't know any of that when this letter came. What did I hear? I heard my father talk about a two-time college dropout whose ideas came to him as visions from a goddess. That's what I heard, and that's what I needed to hear when I was 16. All that other stuff was, I don't want to be anything like my parents, so what's with that? It takes many more years until you're a parent yourself before you begin to recognize the value in that. But what I heard for the first time was, it's not about grades. It's about the quality of your character and the quality of your actual achievements. And I'd never heard my parents say that before. And as a 16-year-old, I needed that. My good friend Amir Axel and I actually ended up writing a book about some of this. So if you want to know any more about that story and how a generation of Japanese mathematicians came to this country, largely in search of this crazy Ramanujan, we wrote a book about it. Okay. So here is a very famous picture. It's one of the few pictures that survive of Ramanujan, taken in 1919. And as was mentioned earlier, we made a film about him. It's the film called The Man Who Knew Infinity. Let me dim some of the lights. It's too bright. Let's see. I have a lot of choices here. Oh, that's pretty good, isn't it? Is that good? So we made a film. It took 8 years to make, called The Man Who Knew Infinity, starring Dev Patel as Ramanujan and Jeremy Irons as a British professor that I'm going to tell you a little bit about. This film is based on the New York Times best-selling biography of Ramanujan, The Man Who Knew Infinity by Robert Kanigel. And I had the very, very good fortune to be invited into this project, first as a consultant to the for math and to the art department. But within a few weeks, and I'll tell you a little bit more about it, I sort of got wrapped up in every phase of the production, and I ultimately ended up becoming, I still can't believe it, an associate producer of this film. Film just came out on DVD a couple months ago. It's now on Showtime. I think our first screening on Showtime was, I think, Saturday or Sunday night. So it's just out there. So if you haven't seen the film, please watch it. We're very proud of it. My friend Dev, we're now good friends. This film was very important to him because it proved that he wasn't just the boy in the film in the Best Exotic Marigold hotel films. If you've ever seen those films, Dev plays a hotel clerk, and I'll tell you, he's not acting. That's who he is. He's all boy. He's all charisma. But in the film, The Man Who Knew Infinity, it was a much more contemplative role, and he did a great job, and he's sort of become a movie star. He recently starred in the film Lion. He was nominated for an Academy Award. It's a great film. If you haven't seen it, I'd love to talk about it. Probably not here. And in a few months, he has another film coming out called Hotel Mumbai, which is also excellent. Great. So just a little bit of background about who Ramanujan was. And keep in mind, this is a true story, and I'm not honestly exaggerating in any way. Ramanujan was born in 1887 in South India, in a small village, and the family was poor. He was born a Brahmin, which, if you don't know, meant that, loosely speaking, he was born into the priestly caste. And it won't come as a surprise that he was gifted. He was an outstanding student as a young boy. He would win awards. If you ever travel to India, I invite you to visit the state of Tamil Nadu, visit the town called Kumbakonam. And if you visit his high school, they will show you some of the awards that he won when he was there. I mean, he is really revered in the country. How good of a student was he? He was so good that he even earned a scholarship to college. It sounds a little bit out of sync with what I said earlier when I mentioned that he was a 2-time college dropout. He was brilliant. He did a lot of mathematical exploration on his own as a young boy, even discovering much of the whole subject of trigonometry by himself at the age of 13. Now that is a little bit weird. What's really weird about that is when he later learned that trigonometry had been discovered before him, he got very upset, and he threw his notebook on the roof of his house. And yeah, I like that. I like the confidence. Let me say that again. I really like the confidence. This is something that we often lose in students because, right, you're supposed to get good grades. You're supposed to go to the right schools, all of those things. But somewhere along the line, a lot of our students today seem to lose that passion, the single-minded devotion to some subject. It's replaced by, I got to get great grades, without recognizing when you're 40, nobody cares what your grades are. So I really like that in Ramanujan. In high school, he received a gift from a friend. It was a book called A Synopsis of Elementary Results in Pure Mathematics, and it was in no way a good book. What is this book? It was a very strange book, really. This is how Hardy would later describe it. It's a book which contains enunciations of 6,165 theorems, systematically and quite scientifically arranged, with proofs which are often little more than cross-references. It's kind of like the ultimate Schaum's outline. So if you know what I'm talking about, you're probably roughly my age. For the younger students, imagine like a Wikipedia of formulas, but only for math formulas. This book ignited Ramanujan's passion for mathematics, and following the style he found in this book, he recorded his own findings in his own personal notebooks. So I have to say a few words about this book, A Synopsis on Elementary Results in Pure Mathematics. The very first line in this book is the equation A minus B equals A minus B. The very next line is A squared minus B squared equals, you all know it, A minus B times. So we have 6,163 more theorems to go. The next line is A cubed minus B cubed. Now you know something happens. A cubed minus B cubed equals A minus B times A squared plus AB plus B squared. Maybe that's not deep, but you know there's something fundamentally a little bit different about that. And then there's 3 vertical dots, and it's A to the n minus B to the n equals A minus B times, I'm not going to say it all, but the same sort of formula. This is the format that one can find by flipping through the pages of this book. And so what is it that Ramanujan found in this book? He found the vertical dots. He found the collection of vertical dots as a collection of personal challenges to him. It was like his video game. He wanted to figure out how you would get from 2 or 3 examples of formulas to a general infinite family of formulas. And therefore it doesn't come as a surprise that Ramanujan will always be thought of as a wizard with formulas, because that's what his true love was. But he was an amateur. He didn't know you were supposed to prove theorems. It wouldn't have come naturally to him. And so in many ways, he's an incredible enigma to us. So as I said, he listed his findings in his notebooks. There are 3 of them. If you ever visit the University of Madras, you can ask the librarian and they'll bring it out. It's amazing. They'll actually bring it out. So when I go there and I ask to see it, I'm always nervous. I really shouldn't be holding these crumbling pages, but I can't help myself. It's something like going to the National Archives and asking to hold the Declaration of Independence. They'd never let you do that. In fact, you'd probably end up in jail. I'm not sure what happened to you. It'd be awful. But if you go to the University of Madras, they'll bring these books out, and you can flip through them, and it's really an incredible experience. Because what will you find? You'll find almost no words, but you'll find page after page of formulas, often where two adjacent formulas aren't even related to each other. So it's a super mystery. Great. So Ramanujan became obsessed with mathematics. He started to spend all of his time on math, and as a result, he couldn't spend any time in any of his other courses. So I don't recommend, although Ramanujan is my hero, I'm not going to recommend to you to not pay attention in your other courses. And I do, of course, recognize that getting good grades is a good idea, but part of my emphasis, though, is that the mindless pursuit of grades is missing out on why you're in college in the first place. So Ramanujan, as a result of his single-minded devotion to mathematical formulas, flunked his courses, he flunked out of college, and he did it twice. How did he do his mathematics? A lot of his mathematics was done in temples. If you've never been to India, imagine temples that reach hundreds of feet into the sky. They're beautifully painted, bright colors, made of stone that was brought from the north by elephant. Imagine, you have to visit it if you try to imagine what these temples were like. It's very hot, it's very humid. And often during much of the year, the only cool places would be like in the bowels of one of these temples. To their credit, Ramanujan's parents continued to support him, which I think is a very important thing, which is what I emphasized to my parents when this letter came. So you see, it's not about getting straight A's. You even said it yourself. So to their credit, his parents continued to support him, and he had other supporters, and he ended up finding work as a clerk to help stave off the poverty. If you ever go to India, you can visit his home, and you can see how Spartan the home was. Okay? And one thing's for sure, nobody in India could understand anything he was talking about. He might as well have been living in a desert. Great. So like I said, we made a film about Ramanujan. That's the beginning of his story. By the end of the story, I hope I make a very good case that Ramanujan should be a household name. And what I want to do in this lecture is I'd like to interrupt me talking with like professional people who know how to talk on film, telling some of the story. So early in this film, some of the first few things that we have to achieve is explain and introduce some characters. So I'm about to show you a film clip where we introduce Ramanujan's wife. But at the same time, I also want to introduce and get the audience to think about what it must be like to be passionate about a subject that you can't share with one other human being. How desperate would you be if the one thing you're passionate about, you've never met another human being care about? Which, by the way, if you are a mathematician, happens all the time. If you go to parties, I study math. There's no better conversation breaker than saying, I study math. But this is taken to the extreme. And so what we wanted to achieve in this scene is we wanted to introduce Janaki, Ramanujan's wife. We wanted to introduce his desperation. And we also wanted to explain, without using formulas, how it is possible that a human being could find mathematics beautiful. So those are the three things that we want to achieve. I hope you think we did it. So let me show you this clip.
Go ahead. You can look. Please.
What does it all do?
It's like a painting, I think. Only imagine it is with colors you cannot see.
What good is that?
Not much for you, I'm afraid. But for me, it is everything. Maybe there is someone else who can see and understand it as well. and for them it will be important.
Have you met them?
No, not yet.
I want to understand more than just colors I can't see.
What do you see?
Sand?
Yes? Imagine if we could look so closely that we could see each grain, each particle. You see, there are patterns in everything. The color in light, the reflections on water. In math, these patterns reveal themselves in the most incredible form.
Great. There'll be a plan. Thank you. All right. So Ramanujan continued in this way for a couple of years, working by night working at the Madras Port Trust as a clerk and working on his formulas in his own spare time. You can't do this forever, and his friends began to recommend that he reach out for help. I like to say that he reached out for help, because everyone needs help. I've never met someone who didn't need help. And the help can come in many forms. It could be parents, it could be friends, it can be professors. There's no such thing as someone who didn't need help. And in Ramanujan, despite the fact he was incredibly original and a genius, and people recognized that, he wasn't around anyone who could understand what he was doing. So Ramanujan reached out for help. He wrote letters to some very distinguished English mathematicians. And finally, he wrote one letter to G.H. Hardy. That's the beginning of the very deep relationship between the distinguished professor in Hardy and the amateur we have in Ramanujan. I love the words that the letter begins with, the letter that Ramanujan wrote. It says, I beg to introduce myself to you as a clerk. I've had no university education. I have not trodden through the conventional regular course, but I'm striking out a new path for myself, and the results I get are termed by local mathematicians as startling. After these words, there are about 8 pages of mathematical formulas, again without very many words. And to his credit, Hardy read some of those mathematical pages. Think about how easy it would be to ignore those mathematical pages. Actually, think about the emails that you get that are spam, that you ignore at first glance without even getting to a second line. Right? These are some of the things that I want us to think about. Right? If Ramanujan were to live today and send us these mathematical formulas, how many of us, me included, would get past the third line? It's not very promising to say, I'm a clerk. I've never gone to college, but I've got wonderful ideas. It doesn't sound like the stuff that's believable. So here is Hardy. This is a very famous, one of the few famous images of Hardy. And we duplicated this image with our actor Jeremy Irons on the right, and I think he did a great job. By the way, Jeremy Irons is a world-class man. He's very humble, he's very shy, but he is the consummate world-class actor. When he arrived on set for pre-production, you could sense it in the crew. We were at a different level when Jeremy Irons was around. And in fact, it was really interesting, chatting with Dev before Jeremy arrived. Dev was frightened of working with Jeremy Irons, and well, I have to say, everybody was on their A game, and I think we all learned a lot from him. In fact, I guess you want to hear some stories about making the film. We almost delayed shooting the film because Jeremy wanted to get the script right. Because I know nothing about mathematics. What I do is I fake for a living. I have to pretend to be a mathematician. And if the scenes don't work, we're not going to film. In fact, I had no idea how true that was. Actually, the very first scene we shot, there was no dialogue. And we spent half a day filming a scene with no dialogue. You might wonder, how is that possible? And in fact, that scene had only one actor, Jeremy Irons. And it was a very important scene. If you haven't seen the film, I won't be giving very much away when I describe it. There's a particular part of the film where Irons, who plays G.H. Hardy, is extremely angry with the university administration because he had been protesting the war. Well, this has happened during World War I. And we are supposed to assume that he has run from his office across campus to the chancellor's office. He just walks into this building, he bangs on the door, and the door opens. We took like 3 hours to film that scene. You might wonder, why is that the case? Because every time we shot the film, Jeremy would go back behind the camera, look at it, goes, that's not right. And then he would go off to the side room, walk around in circles very rapidly for 30 seconds, wait, and we'd reshoot. And I could see the director, Matt Brown, this was his first major film, getting super frustrated because if you don't film on schedule, you lose money. Time is money. And then Jeremy said, we have to get this right. The audience has to believe that I'm really angry and that I've really run across campus. And I'll tell you, I know my face. If my face doesn't look the right way because the blood accumulates in the right way, no one is going to believe that I ran all the way across campus. I'm like, oh boy. All right, this guy is really serious. And it was that level of attention to detail that we applied not only to the filming, but in fact to these scenes. And in fact, that's why I'm showing you some of these scenes, so that when you see the film, you recognize that we actually thought about it. Great. So what were some of the things that Ramanujan wrote in this letter? Some of those things were things that people thought were crazy. You probably think are crazy. Your eyes aren't deceiving you. Ramanujan in his letter wrote that 1 plus 2 plus 3 plus 4 plus 5 going off to infinity, which you probably know to be infinity, Ramanujan claimed, actually that's not infinity. It's not even a positive number. It's not even a large negative number. It's negative a 12. So I will tell you that that's crazy. As stated, it's utterly crazy. But Hardy, as an analytic number theorist, would have recognized that there is a way to make this absolutely precise, connected to the work of Riemann, which was just coming into favor at the time. And so Ramanujan finally found someone who could see some deeper meaning in formulas when the formulas aren't required to be taken at face value. What else was in this letter? I need to tell you about the very last 3 lines of the letter, because it's these last 3 lines that make Ramanujan's story. You see, it's the last 3 lines that were so surprising to Hardy that Hardy decided to reach out and help the 2-time college dropout. So to explain the context of that, I can start with a simpler problem. What is the value of this number x? Where x is 1 divided by 1 plus, 1 divided by 1 plus, 1 divided by. You never need to know anything other than number 1. You don't only need to know how to add, but you have to be able to do it forever. So I'm going to give you a trick. The trick is part of this number is red. And what's important about the part of this number that's red, the part that's red is the whole same number x. So this is an example of a number that lives inside itself. As weird as that may sound, here is a number x that lives properly inside itself. And so if you want to calculate x, replacing that whole expression by x, you really realize that you want to solve this equation, x equals 1 divided by 1 plus x. You can cross multiply to get a quadratic equation, and by high school algebra, there's 2 solutions, but this is positive. The only solution that's positive is negative 1 plus the square root of 5 over 2. So here's a trick that gives you an expression for this infinite continued fraction. It's really beautiful. By the way, another way to calculate this would be to study the Fibonacci sequence and consider consecutive ratios, and you can arrive at this number that way, but this is much slicker, I think. So at the turn of the century, 19th to the 20th, mathematicians were asking questions like, is this formula for minus 1 plus the square root of 5 over 2, is it a standalone trick formula, as I presented it, or is it a glimpse of something much larger? You see, in science, we're often very good at generalizing, but often generalizing just means a minor tweak. This is no easy generalization. So what Ramanujan had in mind was a theory which included that as a special case, but as a particularly simple case. So he wanted to study a function, which is an infinite fraction, where the numerators, instead of always being the number 1, are given by a variable q raised to successively higher powers. So of course, if you plug in q equals 1, you could apply the trick I gave a moment ago to get this expression. But at the turn of the century, 19th to the 20th, the question was, can anyone evaluate the series for other values of q? By the way, this kind of series is studied here at LSU. I know you're not theorists or interested in the connections between knot and variance in these kind of series as well as the number theorists. So Ramanujan had an incredible claim. By the way, if I were to ask you to experiment with this, which is what we might do in a class, I might ask you, why don't you plug in other numbers for q and see if you can see a pattern? And if I did that, my guess is most of you would be like, let's plug in a half or a third, right? Those would be like the numbers that you'd want to plug in. But for Ramanujan, that makes no sense. He said, let's plug in these numbers. They're far more natural. Let's plug in e to the minus pi root n. So if n is 0, of course that's 1. But e to the minus pi root n has three very incredible features. It includes a very complicated number e, the horribly complicated number pi, and then in the exponent, you've got a square root of n in there too. So he said, let's plug in e to the minus pi root n. That makes sense. And he went on to say, if you did that, for example, if you evaluated it e to the minus 2 pi as if that was a simple number for a human being, he said that would equal e to the 2 pi over 5 times this expression. That this expression is given in this way is not what should be surprising. What should be surprising is it's easy to write down this expression in terms of the number I showed you on the last slide, which is basically what's called the golden ratio, one of the most famous numbers in the universe. The golden ratio, it is said to be the most beautiful number that exists, right? The ratio of the Mona Lisa's top to bottom of her face divided by her width is very close to the golden ratio. The same is true for the dimensions of the Parthenon. Same is true for the consecutive cross-sections of the chambered nautilus. It's a very beautiful number. And it turns out that if you plug in for q, these crazy things, the values you get, are all easily described in terms of the golden ratio. Who can see that? If I ask you to plug in for q e to the minus 2 pi with the help of a computer, you can get a decimal expansion, but how would you know that that was this number? To this day, that would be a very difficult problem. All right. So that's how Ramanujan ended this letter, and Hardy found that utterly unbelievable. And using his very words, we crafted this scene. And in this scene reflects Hardy's reaction to this letter that Ramanujan wrote. It's more than that. It's also our opportunity to introduce the character John Littlewood, who was one of Hardy's closest and dearest friends. And how do we set it up? We set it up, well, I'll just show it to you. But the point is that Hardy didn't believe the letter was real. He thought it was a practical joke played on him by his good friend Littlewood. And let me show you how this goes.
You know, Littlewood, this year alone, I've received correspondence from those who profess to prove the prophetic wisdom of the pyramids, the revelations of the elders of Zion, and the cryptograms which Bacon supposedly buried within the plays of the so-called Shakespeare. But a letter from an ill-educated Indian clerk in Madras challenging assertions I made in the track series really takes the biscuit.
Well, I have to say, I've made similar assertions myself.
So you admit it?
But this was 3 years ago.
No, I'm talking about the letter. Bloody brilliant, I thought. I don't know where you got the postmark. Almost had me fooled.
I simply don't know what you're talking about.
Oh, come on. I'm not a complete idiot.
I don't know how to get this into your thick skull, but whatever it is you're talking about, I'm simply not involved. Play.
Sir, you've missed Hall.
Not hungry. I tell you, there is a war coming, no doubt about it. Because we are being led like mindless, spineless sheep, and no one bothers to
question any of it. It's coming all right. You can smell it.
You're as paranoid as Hardy.
With all due respect, Bertie, you couldn't hold a candle. Littlewood, could I have a word?
Yes, of course. Integrals, infinite series, God knows what else. Oh, excuse me. I always forget you don't believe in a supreme being.
All right.
This chap turns out to be genuine, you might have to reconsider.
Well, he must be genuine. Who'd have the imagination to invent all that?
Well, I'm rather flattered you thought I did. These two infinite series are the more intriguing.
Yeah, they defeated me completely. I've never seen anything like them.
Well, it's deceptive. I'll wager the hypergeometric series.
A great Littlewood stumped. He's Hobbes' class, I'd say. Being inexperienced, I would very highly value any advice you give me. Yours truly, S. Ramanujan.
What does the S stand for?
You can ask him yourself.
You intend to invite him here?
Well, no. Much better let him rot away in his office in Madras.
Great. Oh, I don't know why these lights aren't going on now. All right, perfect. Well, now they're all on. All right, well, I'm going to proceed. Okay, great. So what happened, as you now see, Hardy invited Ramanujan to Cambridge, which was an extraordinary invitation. There's a couple things that I have to say. First of all, remember the time period. This was at a time when India was subjugated as a colony as part of the British Empire. Imagine how difficult it would have been to be Indian living under British rule under those circumstances. A great Cambridge professor invited a two-time Indian college dropout. It's like the stuff you can't make up. But there are a lot of other extraordinary things about this. Hardy, as you learned, was an atheist. Ramanujan believed his ideas came to him as visions from a god. So what are we setting up? This is all true. How does someone who is an atheist get along with someone who believes his ideas come from God? Not to mention that they come from two very different backgrounds, one which entirely subjugates the other, especially when the person who's being subjugated is the brilliant one. By the way, if you're wondering about Hardy, you may have all first learned about Hardy in biology class. Do you remember your AP biology exam? The Hardyweinberg Law? This is Hardy of the Hardyweinberg Law. What I really like about that in mathematics, what I can tell you is Hardy did a lot more difficult things than to find an application for the formula 1/2 times 1/2 equals 1/4. Are there any biologists here? I really apologize. No, I don't really apologize for that. It's brilliant, though. Right, okay. All right, so Hardy invited Ramanujan to England, and so how did that work out for him? Well, we have a whole movie talking about that, but this first scene sets the tone for the relationship.
Ramanujan, we decided that for the good of everybody, you should attend some lectures.
But I'm here to publish.
Yes, all in good time, I hope. But first we need proofs of your work.
It's really nothing to worry about. It's simply a question acquainting you with the more formal methods that will benefit our future work together.
I mean, we need a common language. You wouldn't expect us to converse with you in Tamil.
No. But you expect me to speak English.
Quite. So, there'll be plenty of time for publishing.
I'm sorry, but with all humility, how does anyone know that? I don't want this to die with me.
I assure you it won't.
Thank you, sir. But I have much more to share with you. As I told you, the letter only contained a small sampling of my discoveries. You'll see I have even found a function which exactly represents the number of prime numbers less than x in the form of an infinite series.
Exactly.
Yes, I thought if we were going to publish, it should be something groundbreaking.
Oh, this is most unexpected.
Hardy, This will take a lifetime.
Maybe two.
A couple interesting things about this. As I told you earlier, there are actually 3 notebooks. So, believe it or not, we spent so much time trying to get the details right that we discussed probably for an hour. Do we say maybe 3 or do we say maybe 2? Maybe 2 is much funnier than maybe 3. So that's one of the few things that we got wrong in the film, but that was a conscious choice. Okay. So there's a couple things that are important to point out. Not only are there cultural differences and differences regarding spirituality between these 2 characters, keep in mind, Hardy was a professional mathematician and Ramanujan was an amateur. And it turns out that Ramanujan did make mistakes. And so one of the major conflicts in this film is how do you get the professor to recognize the genius in someone he views as an untrained amateur that just has ideas, when the reality is both of them must change. Hardy has to begin to accept that there's someone who has much more brilliant, original ideas than he does, and that he can actually be the mentor by helping craft and harness those beautiful ideas. But the first step is to recognize and help the student, Ramanujan, recognize that he wasn't always right. So, this is how we do it. It's so easy to give a talk when professional actors are giving your talk for you.
Mr. Littlewood has calculated a number, and it shows that your theorem will sometimes predict less, not more, than the actual number of primes. Your theorem is wrong. And this is why we cannot publish any more until you finally trust me on this business of proofs. Intuition can only carry you so far.
Stop! I can't hear this anymore. Intuition? You say this word as if it is nothing. Is that all it is to you? All that I am?
Look, I'm sorry. I'm missing something.
You've never even seen me, let alone know me. You are a man of no faith. I don't see pictures of anyone here, not even family. Who are you, Mr. Hardy?
How dare you? How dare you judge me?
But it is you who does of me, don't you see?
No. Quite frankly, I don't.
Don't you know what I've given up to be here? I have nothing. Do you even see the bruises on my face? I have a wife, Mr. Hardy.
Seconds. Jeremy Irons really has quite an he's really good at facial expressions. It's really incredible. Actually, one small story. We delayed the filming of Batman versus Superman to finish this film. I was very proud of that. So Jeremy Irons played Alfred the butler. Actually, you have no idea how crazy my life has been. We filmed this at Pinewood Studios when they were filming Star Wars 7. You might have heard that Harrison Ford broke his leg a couple years ago, 2014, falling off of a golf cart. I was there. It was crazy. The people that I met that week, those few weeks, it was literally unbelievable. But getting back to the story, I was going to tell you, it was super interesting watching Jeremy go through these lines, switching back and forth between Alfred the butler and Jeremy and G.H. Hardy. It was really gifted. Okay. So now the turning point. Some of you might ask questions about what did we manufacture in the film. I'll get to that later if you want. But the real turning point is, as I said a little bit earlier, is how does the mentor finally embrace the idea of being a mentor, particularly when that person is so antisocial, a curmudgeon, as you had in Hardy. And how do we explain that? Well, it was actually very easy to do because we just tell the truth. You see, in Ramanujan, you had someone who was so naturally talented and who was so naturally passionate about his subject that it almost came too easy for him. Most of us in science have the benefit of reading papers that lead up to the questions that we consider. And in the course of doing that, you get appreciation for the hard effort that preceded you. and you get to see where your role is in the development of science, however big or small it may be. But for Ramanujan, his ideas came as visions from a goddess, so it meant nothing to him that there was a universe out there who would have killed to have his talent. How do you begin to harness someone that is that gifted? By the way, it probably sounds very familiar to not a beautiful mind, Good Will Hunting. What I just told you was literally some of the things that Ben Affleck and others had in mind in crafting Will in that film. So how do we portray and illustrate this transformation? We told the truth. We had to have Hardy explain to Ramanujan what the future meant for him if they completed their work in terms of what would his role be in the history of science. And I think this will be the last film clip, and then I'll talk.
How did you know that theorem?
It came to me. Mr. Hardy, I don't understand why we waste our time doing all these proofs. I have the formulas.
It's not that I can't see what you've claimed. It's that I'm not sure that you know how you got there. Or indeed that your claims are correct. There are subtleties which...
But they are right, sir. I have more important new ideas.
Yes, but intuition is not enough. It has to be held accountable. And a little humility would go a long way. Why do you think they want us to fail?
Because I'm Indian.
Well, yep, there is that. But also because of what we represent. Now, Euler and Jacobi, who were they?
Mathematicians.
Just names to you. Euler was the most productive mathematician of the 18th century. Most of his work done after he was blind. Jacobi, like you, was snatched from obscurity and was almost as impressive as Euler. Now, I think you are in their class. What they had in common, what I see in you, is a love of form. It's all through your notebooks. Let me ask you something. Why do you do it, any of this?
Because I have to. I see it.
Like Euler. Form for its own sake. An art unto itself. And like all art, it reflects truth. It's the only truth I know. It's my church. And you, just as Mozart could hear an entire symphony in his head, you dance with numbers to infinity. But this dance, this art, does little to endear us to certain factions who see us as mere conjurers. So if we are going to challenge areas of mathematics that are so well trod, we cannot afford to be wrong. I need you to attend your lectures, don't offend your professors, and keep doing your proofs. Otherwise this experiment of ours will be doomed to failure. Come with me. I want to show you something. There are many ways to be honored in life. For us, being elected a fellow is certainly one, but in my humble opinion, to leave a legacy here at the Wren after we're gone is the greatest. This library houses the epistles of St. Paul, the poems of Milton, Morgan's Bible. But in my estimation, as a man of numbers, the pièce de résistance is Newton's Principia Mathematica. Now, just as Newton represents the physical aspect of our work, your notebooks represent the abstract. It took a long time for Newton to be proved, which is why we have an obligation to prove these. And if we do, I believe that one day, these notebooks will find their place here. Now, do you understand what's at stake here? Good.
Great. Well, you don't, yeah, perfect. So, if you've seen the film, I hope this commentary sheds some extra light on what we were thinking when we were assembling these scenes. By the way, the dialogue in this scene was extremely difficult to write. Even the first few sentences. It's not that I cannot see what you've claimed, or indeed that your claims are correct. We spent hours getting that right because I said, mathematicians will laugh at us if we don't get this right. If Hardy is a professor, what does it mean that Ramanujan is writing stuff down that he can't see? How do you explain that? So if you go back and see the film again and think about it, I hope you appreciate that we really spent a long time thinking about that. So how does the Ramanujan story end? Well, Ramanujan ended up writing 30 papers in England, some with Hardy. He overcame racism and the difficulties of World War I to do this. And as a Brahmin, it won't come as a surprise that he couldn't eat the English food. He was a vegetarian. Of course, if you go to England now, there's almost like no such thing as English food. It's all Indian. Yeah. And despite these hardships, for his field-changing work, and it's rather extraordinary, Ramanujan was elected Fellow of the Royal Society. The Royal Society is a wonderful thing to be a member of. It's one of the highest honors you can win as a scientist working in the British Empire. You're invited to a ceremony in London near Trafalgar Square. You get to sign your name in a book, and one of the first pages in this book has signatures by like Isaac Newton. You get to join the company of some of the most distinguished scientists ever. Ramanujan was elected Fellow of the Royal Society at the age of 31, and he was the first Indian elected a fellow. It's actually very important to note that he was elected in 1918. Next year is 2018, and to mark the occasion, we're going to have a major conference in London where lots of dignitaries, royalty will come to celebrate Ramanujan. This two-time college dropout, his image is all over Cambridge University, it's all over the website, and next year will be particularly striking and important because I want to note that the new president of the Royal Society is Indian, the first Indian to be elected president of the Royal Society, and he was from a small town in South India, and growing up as a boy, he was inspired by Ramanujan. He didn't get into the best colleges, and in fact, he ended up getting into graduate school in the United States. He earned his PhD. His name is Venki Ramakrishnan. We're good friends now. You might know Venki because he is one of the scientists that also talks about religion. Venki went to Ohio University for his PhD in chemistry. I don't mean Ohio State University, I mean Ohio University. Not one of the places where you would expect a Nobel Prize-winning chemist to be trained. And he didn't get a job out of his graduate school days, but amazingly, 10 years later, he won the Nobel Prize in chemistry for figuring out a lot of RNA transcription. And we screened the film a year ago, and he broke down in tears saying, actually, I'll start crying because it was, I can't because I remember it, about how he was inspired by the story of Ramanujan, and that story kept him going. He could have quit many times, but now he's president of the Royal Society. So I think it's wonderful that we made a film at a time where lots of things are quite positive, although a lot of things, I think, require our support. All right. Unfortunately, due to malnutrition, Ramanujan fell ill. We depict this in the film. He returned to India seeking a return to good health and Indian food, and unfortunately, it wasn't meant to be. He would die within the year. He died on April 26, 1920, and he was only 32 years old. And he continued to produce mind-blowing math from his deathbed. That is no exaggeration, okay? A lot of the recent breakthroughs in black hole physics make use of the understanding that we've gained from this last letter of Ramanujan's life. There's a foundation called the Simons Foundation that is supporting us for 3 years of conferences to talk about black holes, string theory, quantum gravity as motivated by Ramanujan in one 3-page letter. It's crazy. By the way, for the students, I kind of want to get a show of hands. If you're a mathematician here, stand up if Ramanujan somehow impacts your field. Please don't embarrass me. If you work in number theory, right? I know there are others. Your chairman is not telling the truth, all right? And there are probably some others, so you can all sit down now. I want you to know that I'm not exaggerating. Here at LSU, probably a third or a half of the faculty members know that Ramanujan has somehow impacted their lives. Now I want to do something much more striking. Please stand up if you own a smartphone. If you don't stand up, I literally don't believe you. All right, you may all sit down now. I think you know my point. The most advanced protocols that your cell phone uses in terms of what's called graph signal processing makes use of some protocols developed by P.P. Vaidyanathan. He's a very well-known electrical engineer at Caltech. Just last year, he won the Kirchhoff Prize for developing these protocols, and it's in your phone. And what mathematics does he use? The theory of Ramanujan sums. I think Ramanujan is a name that deserves being a household name. Great. So what do we learn about Ramanujan? Well, there's first the mathematical legacy. And, well, his ideas have inspired lots of us. Fields Medals have been awarded for his work. Later this week, on Friday, I'm going to talk about the modern formulation of what's called moonshine, which has incredibly been revitalized due to his ideas. Even the proof of Fermat's last theorem, you could argue, would not be known had it not been for some of Ramanujan's early formulas. But the reason we made this film, and it's the reason why we're beginning to make other films about important scientists, is the second answer. And in the case of Ramanujan, the broader legacy is this, and it's that talent can be found anywhere, even in the most unexpected and unforgiving of places. And so to fulfill its potential, it has to first be located, recognized, and then properly nurtured. We all recognize that. The question is, do we recognize it enough to the point of action? Right. So now I'll conclude this lecture with a number of mathematical gems. I think I made my point with your cell phone, so let me show you some beautiful mathematics. I almost cannot give a talk without talking about what are called integer partitions. There's a function called p that counts the number of partitions of integers. It's very easy to describe by way of an example. If we start with the number 4 and break it up as a number as a sum, these are all the ways of writing 4 as a sum. And if you count them, 1, 2, 3, 4, 5, there's 5 ways. So we say that p of 4 is 5. It looks like child's play, adding and counting. And it turns out there are 22 ways of partitioning 8. And believe it or not, if you're ever lazy, not lazy, if you did this, you certainly wouldn't be lazy. If you're ever bored, if you try to write down the partitions of 32, you would start with 32, 31 plus 1, 30 plus 2, 30, right, you get the idea. And by the time you get to 32 ones, you'll have written down 8,349 ways, or you miss some. This function grows at an astronomical rate. Despite the fact it's easy to fathom how you would go about computing this, the calculations are actually just ridiculously prohibitive. So one of my favorite theorems of Hardy and Ramanujan together is this asymptotic formula. It's one of Professor Barry's favorite. And it's that p of n is asymptotic to 1 over 4n root 3 times e to the pi root 2n over 3. That's not obvious. It's actually a brilliant method that was invented to calculate this. And this invention is now a modern tool, standard tool in the theory of numbers. It's called the circle method. And as a graduate student, I was inspired just by hearing of this crazy formula, because it indicated that some problems that are so simple to state actually are hiding beneath them very difficult structure. Okay. Here's a story I have to tell you. Maybe some of you know it. If not, let me briefly tell you how it goes. So Ramanujan, as I said, got very ill in England, and Hardy would go visit him. This is the story of one of Hardy's visits to Ramanujan when he was in the hospital. So these are Hardy's words. I remember once going to see Ramanujan when he was ill at Putney, and I'd ridden in taxi cab numbered 1729 and remarked that the number seemed to me a rather dull one. No, Ramanujan replied, it's a very interesting number because it is the smallest number expressible as a sum of 2 cubes in 2 different ways. That's weird. This story is often cited as an example of what Littlewood said about Ramanujan, namely that to Ramanujan every number seemed to be like a personal friend. Who just knows crazy facts about 1729 being the sum of two cubes in two different ways and being the smallest one with that property? People don't just remember facts like that, like you might remember baseball statistics. So let me tell you, that's not how this went. So a few years ago, Andrew Granville and I, Andrew is a distinguished analytic number theorist working in London, we visited Cambridge. We went through the Ramanujan archives, which I've done many times before, but I don't know why I missed it. But on this particular trip, we found this page. The folder doesn't have any help. The folder doesn't have these fingers pointing to delightful gems, so I'm helping you out. There's a finger. And next to this finger, you see 9 cubed plus 10 cubed equals 12 cubed plus 1, which are two expressions for 1729, keeping in mind that 1 is 1 cubed. So it isn't true that Ramanujan just happened to know this fact. What's closer to the truth is that in his notebooks, he'd written down this fact and he remembered that he calculated that. So it makes you wonder, what in the world is on this page? So let's look at what's on this page. It says Ramanujan found 3 rational functions in X. And I don't want you to memorize that. I want you to look at those rational functions in X and think, I wouldn't just imagine that on my own. That's all I want you to think. What's special about these 3 rational functions? Well, if you express each of them as power series in X, like you would in calculus, you would get coefficients, alphas, betas, and gamma. And what turns out to be true, which he didn't prove, but is true, people later proved it, is that the coefficients of these series, in order, without exception, satisfy this equation. A of n cubed plus b of n cubed equals c of n cubed. And if you know Fermat's last theorem, you know I can't stop. Because Fermat's last theorem, among other things, implies that the sum of 2 cubes could never be a cube again without one of them being 0. So what's true? The sum of these 2 cubes is the other cube, but plus or minus 1. He found infinitely many near misses to the Fermat cubic. And what were near misses? Alternating by 1 too many or 1 too few, in order as the coefficients of these series without exception. Now I'll tell you, I can give this to graduate students and they can prove it. But nobody is ever satisfied by proving that on their own. They're left wondering, how in the world did Ramanujan find these 3 not very natural looking functions? And that gives you a clue to the kind of thing that Ramanujan did over and over and over again in his notebooks. He offers formulas. Most are right. Some are not quite right, but in spirit right. If I give you the formula, we have the technology to prove them. What we don't know is where they came from. And a lot of them have this mysterious property to, God, I wish I knew how he found them. And if I'm lucky enough to get even a hint of that, maybe I could win a Fields Medal or win, and I can't tell you how many times that has happened. Basically, every Fields Medal, including Falting's Fields Medal, has had some inspiration somehow from crazy formulas found in Ramanujan's notebook. Ramanujan was a man who lived long before his time, and he left behind the barest of glimpses of theories that have powered some of the most important mathematicians of our generation. What is this really in disguise? This is in disguise the first inkling of what's called the theory of K3 surfaces 30 years before anyone knew these objects existed. All right, my time is up, so I was going to talk a little bit about what inspired Manjul Bhargava when he got started in his career. I might say it later, but I'll conclude with Ramanujan's deathbed letter. I said a few words about it. From his deathbed, just 3 months before he died, Ramanujan wrote one very last letter to Hardy. It begins with the words, "I'm extremely sorry for not writing you a single letter up till now. I've discovered very interesting functions recently, which I call the Mach theta functions. They enter into mathematics as beautifully as the ordinary theta functions, and it took mathematicians basically 100 years to figure out what he was talking about." You can go hold his letter. So this is me holding that letter. And let me just say, we have now figured out what that letter means. And it is indeed true, it's extraordinary. This theory of Mach modular forms are now populating many different areas of math and science. And if you've seen our film, or if you haven't seen our film but see it later, and then you see this closing screenshot, which says that a century later these formulas are being used to understand the behavior of black holes, that is true, and we're referring to that letter. For those of you who know about the deconvolution of black holes related to gravitational waves, put another way, maybe you remember seeing in the news last summer those cartoon animations of black holes colliding. Some of those equations use what are called multi-centered black holes, and the study of that by Atish Dabkolar uses these functions. So one of the biggest news stories of the year last year is connected to this last letter that Ramanujan wrote. And I'd like you to keep in mind that he wrote this letter at a time when nobody believed that black holes could exist. They thought it was a poor interpretation for a differential equation in gravity theory. Well, we've now seen them. Great. So that's what I wanted to say. I hope you agree that it was a film that had to be made.
Okay, yes.
I have a question. I love the lecture and I'm so glad that I came. I don't want to focus on the negatives. You said that there were, you referred to a mistake that was found in some of the work that he did. When they had looked at his work, they had found lots of mistakes, or this was one of the only cases that you find a mistake?
So were there many mistakes in Ramanujan's notebooks or in his writings? Well, remember he wrote thousands of formulas, so what does many mistakes mean? There are really two kinds of mistakes. There are very few mistakes that were clearly wrong. I don't want to go on the record to say that they were clearly wrong, because there have been instances of formulas that we called wrong without understanding that we misinterpreted what he had in mind. Believe it or not, even in Ramanujan's notebooks, the symbol equal sign had a different meaning for him in some cases than it does for the rest of us. So there are a few probable wrong mistakes. There are other claims that are mildly wrong, but remember, these are his notebooks. He never thought, I don't believe he ever thought that mathematicians would be poring over his personal notebooks 100 years later. These were notebooks for himself. So I think it's much closer to the truth that basically everything was right.
How do we go about finding the next Ramanujan?
How do we find the next Ramanujan? That is a great question. So after I can tell you what we're doing, but everybody should do their part. If you have a neighbor that's gifted in math and they're told they're not supposed to do math or not go into science, encourage them to follow their passion. In fact, I do this at Emory. The last question on my final exam in every course is, what are you going to do to make the world a better place? Because I know that in the courses that I teach, there are a lot of very stressed out kids who are taught or brought up believing they're supposed to be a doctor or they're supposed to be a lawyer, rather than trying to choose a life that they think is meant for them. They're choosing to live a life that they believe was meant for them, which, by the way, is the worst thing you should ever do. I have recently had my 25th college reunion, and it's kind of a bummer to see friends who have, on paper, wonderful jobs, probably making 3 times as much as me, but totally unhappy. Or others who have just finished paying off their medical school loans, and now they're worried about how they pay for college, and they covet my life. It's weird. So how do we find the next Ramanujan? Well, we are working with the Templeton World Charity Foundation. I screened this film with the actors in Silicon Valley at Uri Milner's house with some very famous people. This is when they announced the Breakthrough Starshot conference, where they were going to send little spaceships to outer space. And I gave a talk not very different from this, and the president of the Templeton World Charity Foundation said, we should do what you're saying. We should, just like SETI is searching the skies for extraterrestrial life, we should be searching the planet for talent. So we're giving out scholarships. We're giving out $100,000 of scholarships this year to people who are talented but without means. And so if you know someone who wants to apply to our scholarship, go to my website, learn about it, and we hopefully will make it happen. I found a kid in Kenya in December who had discovered mathematics on his own. I brought him to the joint meetings in Atlanta, and I introduced him to many of the mathematicians who were there, and I guarantee he's going to be a very important mathematician. We've given out 7 awards so far, so if you know someone that is in need, right? I don't need to go to Boston and elite, I don't have to go to Phillips Exeter and give someone a scholarship. I want someone who might not otherwise be able to go to college, or someone who can get into like the Promise program, or who isn't a US citizen but could benefit from an REU program but can't afford the flight. We want to pay for that. So we have formed something called the Spirit of Ramanujan Global Talent Search, and we want to play the role of Hardy for people who want to follow their passions, who might not otherwise be able to. So thank you for asking that question. I would have totally forgotten that we were doing that.
Other question? Well, this is the first of 3 lectures. The second and third lectures will be held tomorrow at 3:30. They're going to be in Dodson Auditorium, which is on the football stadium side of the quad. There'll also be refreshments served in the lounge in Lockett Hall in the math department before the lecture. This was clearly a truly inspirational lecture. Let's thank Professor Ramanujan.
So if you're wondering about more films, if you like our films, there are more in the works. If you've never heard of Hedy Lamarr, we've got a film project about Hedy Lamarr. If you've never heard about her, Google her. She's the most beautiful woman in the world. She was a famous actress. She acted with Clark Gable, but together with George Antheil, she invented frequency hopping, which is what Wi-Fi satellites use. It's an awesome story. We also have a film about Emmy Noether in the works, and we also have a film about Nikolai Tesla with Jared Leto. So we think there is a demand for these films, and look for them. Yeah.